This video is about bias. Bias is anything that affects the outcome of your study that is not what you're trying to test. There are a ton of sources of bias. I'm just going to cover the ones that come up on tests most frequently. If you want a more comprehensive list, take a look at the notes. All right, let's break this down based on some sources of bias. Research subjects, or study participants, are one source. Researchers themselves are another source. And then there are some biases that are just inherent in doing research. These we'll say come from the study. All right, bias that comes from subjects. First one that you need to know is the Hawthorne effect. Now, in the Hawthorne effect, people change their behavior because they know that they're being observed. So, observation leads to behavior change. The next one that you need to know is recall bias. In recall bias, the way that I want you to remember this is that sick patients remember more. So this happens in retrospective studies where you have a group of sick patients and a group of healthy people, and you ask them to think back to exposures in their past. And people who are sick are going to think just a little bit harder about exposures that they might have had out of an eagerness to explain their illness. And the way that you address bias that comes from subjects is with blinding. That's where you don't let them know what group they've been assigned to. And when only the subjects are blinded, that is referred to as single blinding. All right, so bias that comes from the researcher is a much bigger deal, but fortunately it is also easier to address. The first one here that you need to know about is selection bias. In selection bias, at baseline, the groups that you're comparing are different from each other in a way that they shouldn't be. So, for example, if I'm a researcher and I put all of my sickest patients into the group receiving the study drug and all of my healthier patients into the group receiving the placebo, I can't really make a fair comparison at the end of the trial. So that's selection bias. You can think of it as groups are different at baseline. And the way that you address this is with randomization. That is, you don't let the researcher pick who goes into what group. You do a coin flip or a random number generator so that it's based on just random chance, not based on what I want as the researcher. You can't always do randomization, and another tool that you can use to address that is matching. So that's where for every person in the study group, you get somebody who is similar to them, who matches them in terms of demographics, and you recruit them for the comparison group. And the way that you show that your matching and your randomization have been successful is you show that they have similar demographics, and you compare these in a table. All right, next one you need to know about is observer bias. In observer bias, the researcher knows what group everyone has been assigned to. They know who is getting the placebo and who is getting the study drug. And their knowledge of this impacts the way that they evaluate everybody, consciously or unconsciously. So, researcher evaluates differently. And the way that you address this is you don't let them know what group people are in. You blind them. And when both the researcher and the subject have been blinded, this is double blinding. All right, so let's move on to sources of bias that come from just doing research itself. Next one I want to talk about is confounding. Confounding is the most important topic in this whole video. If you learn nothing else, learn confounding. All right, so what confounding is when you have an exposure and you have some outcome and you see that they are related, so you think, hey, the exposure must be causing the outcome, but you are wrong because there's a third factor that you did not think about that is related to both the exposure and to the outcome. And that third factor is distorting the relationship between the exposure and the outcome. Let's talk through an example. Bizarrely enough, ice cream consumption is associated with an increase in drowning deaths. So I might be tempted to say, hey, ice cream consumption causes drowning, but I'm wrong because I didn't think about summer. Summer causes ice cream consumption. Summer also causes drowning deaths. And when I account for this fact, the relationship between the exposure and the outcome disappears. That's confounding. Ways that you address this, you can do good study design, or you can do randomization. You can do matching. Either one works. Do not confuse this with effect modification. So effect modification technically is not a bias. I'm going to put it in little parentheses here. We need to discuss it here though because it gets confused with confounding so easily. And let me show you why. Just like with confounding, we have our exposure and we have our outcome. And we think that they're related. And there's even a third factor here. And the third factor is associated with the outcome. The difference here is that the third factor is not related to the exposure. And this is key. The third factor enhances the relationship between the exposure and the outcome. Let's talk through an example. Oral contraceptive pills, OCPs, are associated with a small increase in the risk of DVTs. If you look a little bit closer, you see that it is not just the OCPs that is causing the increase in DVTs. It is oral contraceptive, OCPs, and smoking together that causes the big increase in DVTs. Smoking is not really related to OCPs, but when you add smoking to oral contraception, you have a modification, an enhancement of the effect. And that is the key difference here. When you add the third factor, you get a stronger effect. Okay, so just to do a quick recap, when you have bias that comes from subjects, you want to blind. When you have bias that comes from the researcher, you want to blind again, double blind. You also can use randomization and matching. And do not confuse confounding and effect modification. Remember that in confounding, your third factor negates the relationship between your exposure and your outcome. And in effect modification, your third factor enhances the relationship. And that is bias.